even though you're seeing stains on it. Trying to think what went wrong on this one. Wasn't burning through.
So that is stainless.
Stainless.
It just got the rust attached to it because it was sitting up on top of that.
Yep.
And this one is not stainless.
That's stainless also. It just got transfer.
Yeah.
You can also use a magnet, and a magnet will stick to the non-stainless, and it'll not stick to the stainless.
Got it.
So this is all stainless, but kind of hard to work with.
This was left over from that room, right?
Yes. The perf, yeah.
No.
They only sold it in 4-foot wide pieces.
Not stainless.
And I only needed the bottom 32 inches or whatever it was. So what you're going to be exporting across is DXF, and it has the same problem that you're familiar with, that DXF doesn't do fonts. So all of your actual letters,
Text explode.
it needs to
Text
be
explodes.
text exploded, but you need to do text explode anyway, because if you can see on this one, it's taking away the letters, right? So I needed a way of holding on to the centers.
Right.
So there's two concepts, right? You were doing a sign that left the letters,
Right.
right? And then it's pretty easy to blow out the little holes and let them drop out.
Yeah.
In this case, we were getting rid of the letters, because this is from Idealab. And so we need really strong tabs to hold on to the things. So in some ways, you need to use text explode anyway in order to go in here and add lines and trim
Right.
and all that, so that it becomes a bunch of line segments. But as you know, once you do text explode, your file becomes enormous.
Giant. Yeah.
Because this turns into 1,000 little line segments. So it's something to keep in mind. Was supposed to be the new one with MyPlasm, because this one I think had your Bridge software on it, and I didn't want to have one computer do both MyPlasm and the Bridge, so I wanted to have them separated. So I had them add MyPlasm. I think it's to this one, so it's one thing to verify right now, and then we'll just separate them. So a couple different things happen on these.
You don't mind if I'm recording, right?
No.
Okay, good.
And you're getting the screen?
Yes.
So cool. So a couple different things. When you turn it on, there's a few things you're going to find. It says USB device not found, and that's this referring to that it's not connected to the controller. So now it should have that you have to do click to reset, connecting. I don't think we can update because we're not on. Yeah, usually I don't update because once you update, then you have to get IT involved. Yeah. So now it says communication okay. That means that this is talking to the machine.
Nice.
So that's a good start. Up in here, it's a little confusing where you start with. Is that you're going to start with this import file. An import file lets you take things. Sometimes it's a little tricky to have it find where you're looking. Like these are looking at things that are like, I think already preloaded in the software. So it's weird if you think about this. Do you see how there's an open file folder here?
Yeah.
You don't want that one. You need to do the import first and then you click on the open folder. Yeah.
Got it.
And now in here, we're gonna go look for, instead of the MyPlasm examples, we'll go to D and we'll find a bracket. And okay. And so now this bracket is here, and so you need to like send it into My Minicad to look at it. So that's this send thingy right here. Now
What is the send thingy?
it's this little green arrow that's saying now like I want to go work on it.
Okay.
And now you're in this environment which is kind of like CAD, but it really isn't. It allows you to do very rudimentary things. You can scale things, you can flip things, you can mirror them, but pretty much you want it to come across looking right. But it's at this stage that you need to look up here, and I don't know why randomly, like I think the last time I ran this, it came out fine. That is not fine.
Is that in inches?
That bracket is this long.
Right, yeah, I remember you showing it to me.
So what is 135? So maybe, and so if you grab all of it, and you can go to scale, which I think is this one, we can say point, I'm just going to guess, 03, what is it, 0393? Isn't that the millimeters to inches? Yeah, that looks about right now. So let's just pretend that was the scale. It was 1 divided by 25, right? It was millimeters to inches. Sometimes it comes in right, sometimes it comes in wrong, but you always need to check, is your size logical over here? And that is the actual finish size from end to end and top to bottom, not of an individual part, but the whole thing. And you're like, yep, that feels about right. Now what you're going to do is look at the red dots, and you're going to see over here that it's saying, is there an offset, and is it outside or inside? So normally there'd be an offset, and wow, this whole thing got changed to millimeters. See how this is millimeters?
Mm-hmm.
Oh, I wonder if it's this machine.
Oh, because the other computer.
I think the whole thing was in, and that's why this green arrow is so wrong. So, let me do this. We'll keep it in millimeters, because everything's going to look funky if I do it not. We have to do something else to fix that. So, because what I was looking for is this. Do you see how this is a hole, and the green path is on the inside of the hole?
Yep.
Even though this is clicked outside.
It's still showing inside.
What it is you're basically telling you want it outside the outside-most perimeter.
Oh, like right down here?
And this is green here,
Right.
right? And so it's outside the outermost, which means it automatically knows that if there's any other feature interior of that these are automatically inside. Can you imagine what would happen if I had a gap somewhere here? Can you imagine what would happen to this one?
It's also offset now.
It's still on that. It will think it's on the outside.
Yeah. So what you'll find is every now and then, if you look at your object and this says I'm going to plasma to the outside of this part, good. But what if it did to the outside of this one? It means you have a hole somewhere.
Okay.
And it doesn't recognize that this is an exterior feature and an interior feature.
Okay.
And here's the only control you have. You can click inside or outside. You can't click one object and tell it inside,
okay.
and you can't click the other object and say outside. It does the whole thing either in or out. So now you'll notice it's plasming to the inside of the outer perimeter and to the outside of the inner perimeter. All very bad. So generally you want to be on outside. And then, because what that means is you're cutting outside of an outer part.
Mm-hmm.
Notice this is just a line. And when it gets a line, it starts the plasma right there and then does it in one pass. It does it on the line, right? These, it's actually showing it's off the line. And it's doing that by an offset of,
Sorry.
no problem. The offset on this, where is the...
Does it give you like a number?
Yep. How do we choose that number? That's a lead-in. So lead-in lets you choose, and usually lead-in is on. Oh, you know what? There's no guarantee this machine is actually set up. Remember all those settings I was telling you about?
Yeah.
All the gear ratios? This one hasn't been set up yet. So we wouldn't want to cut anything with this machine. That
Should
one's
we
all
jump
set up.
over to that one?
We can. But while we're on this, do you see what lead-in did? Lead-in moves the plasma to start here, and it starts in the middle of the hole, or it starts 3 millimeters away, and then it sweeps in and makes the cut. What that does is it creates burnout holes. So see that? That's where the plasma starts.
Got it.
So by starting off of the line,
You prevent that.
you prevent that from
Yeah.
looking ragged, right?
Right.
And you want to make sure that it's got a lead-in.
Mm-hmm.
Notice, what will the lead-in be on that? There isn't any. It's going to blast and make a line. So what that line's going to look like is a hole with a long tail. And, just as long as you're aware of that's going to be... Now, if you don't like where this is, so look where this is cutting.
Oh, yeah, it's too
Oh, yeah,
The
we don't like
lead-in
that.
is in the other part.
Yeah.
So what you can do is you can I think it's right click. Yeah, I can right click where I want to recommend it to start. And so it's just a right click, and I can click kind of anywhere around. And
you're in the lead. You've got that highlighted, right?
I think it's just that I'm anywhere in here.
In my mini CAD.
Yeah, and I just right click and I can tell it where to put that lead in.
Got it.
You can also change the size of the lead in. So I can't remember how to do that. And then you can also have it lead out. So when it gets done with a cut, I don't turn that on very often. It doesn't seem to create a big burnout on the way out. So I just do lead in. Oh, and then here you can adjust it with a slider.
There you go.
But I kind of leave it on that setting. So what this is all about to make is that these are stitch lines. And when you put a series of those in there, it makes it easy to fold it on the brake or even in the vise. So I'll put these in here so that it kind of acts as an indicator and also acts as a fold line. It's like the perforations on a paper towel.
Right.
So I wanted this edge to be folded up. And the problem I had at the beginning was that these lines touched the outer perimeter, and then it got confused because it saw an open perimeter, because this line came along here and then it had this weird tail in here, and it didn't know how to deal with that, and it wouldn't let me do inside or outside. It would only go on the line. So I went back into AutoCAD, trimmed out a little tiny gap so that now it sees a perimeter and it sees a stitch line, same thing over here, and then it was okay with it. In actuality, this was so close that when it burned this, it actually burned it all the way across. So it kind of worked to my advantage that software-wise, it was fine with it, and from a hardware-wise, it was cut all the way through. There were a couple that weren't cut. I had to use an angle grinder and just snip the rest of those through. Right? Again, trying to do nesting, right, as a normal thing. Once we're all happy with this, and this one is kind of annoying, it's off here. That might be off the material. I'd rather have it do a lead in up here.
Right.
Because this kind of wasted space anyway. Yeah. This might be off the part, and it can't start off the part. You know, if your material's over there and the plasma starts off here in the air, it can't create an arc, and then it won't start. So we need to tell it, put them there, and then once you're all done, it's this check mark. Not obvious, because you use the arrow to put it over here, and you use the check mark to send it back.
Okay.
Now you're in MyPlasm. So we were over in My MiniCAD for a minute as the setup, and now you can kind of go back and verify. It doesn't show the cutting offset, but it does show there's the starts and all that kind of stuff. You verify. Now it had an e-stop, which is interesting.
Maybe twist it. E-stop.
It looks like it crashed.
There's the e-stop, emergency
And
stop.
if I go, nothing's moving over there.
twist the
Oh,
e-stop.
it looks like this got
Maybe it got
pushed.
pushed.
No, but that's what it appears happened. And it's showing something here. I'm gonna try and do a reset. Disconnected, connecting.
Make sure that's
E-stop.
out.
Maybe press the E-stop in and then twist it again.
And that actually said limit switch. Weird. So I'm not going to count on this one because I haven't actually run the plasma. This one's all been set up, so what I need to do is have this one running and this one running at the same time. Yeah, it's that one right there. And okay, same part. And it's 5x3.
Oh, nice.
And we'll reset this. Oh, of course it's not finding it because it's not plugged in
USB
anymore.
not found. Okay.
And hopefully, like this kind of stuff would just be set up all the time.
Yeah.
But this often, when you come back from it being non-running for a while, this might be off.
Yeah.
And this is just a reminder that you're like, oh yeah.
No more E-stops. That's good.
No more e-stop, and there's only one of them because I think I only needed one more. It's off the side, so we could say we wanted to go work on it a minute. We want to take this over and work.
Send it.
Yeah, but see, there's no send.
Yeah. What happened there?
So
Wait, how'd you get
It's,
that?
I just clicked on, shoot, what did I click on? I clicked on this import file. Even though we're not importing, it's the way to go look at it, and then we can say, yeah, take it over to My Mini.
My Mini.
Oops, but it took that one. It didn't take the bracket. All great examples of how to
Troubleshoot.
Okay.
how to troubleshoot, right? Open the folder, bracket 3, open. Now we're going to send it over, okay? And then now, oh, the other thing, and yeah, this one's set up as non-metric. So you can see the tool size is 26 thousandths. We're going to get some of those settings from our data sheets. So we need to know what we're machining it out of. So whether you're, say, mild steel or stainless steel, both are using, in this case, the fine cut, and it's this head. So this head is different, and if you're using this head, this is a 65A, so that would be using this data sheet. So you have to match the cutting head, and this is mild steel 65. If we were doing stainless steel 65, we would have to find that data sheet separately. And it's based on the bigger the number, the thicker that you can go. So this one goes up to 10 gauge, and well, it starts at 10 gauge, and it looks like goes all the way to 1 inch thick, solid steel. Whereas this one starts off at 26 gauge, which is pretty, that's thin. That's this kind of, it's kind of like this stuff, right? And then going all the way down to 10 gauge, which is more like that,
Oh, wow.
right? So this is like 1/8 of an inch thick. So it'll do, and then like when I did the quaking aspen leaf, you know, that stuff is 3/8 thick. So that was using this, like using this head and using the 3/8 and reading across. So you have to make sure you're using the right head and then using the right chart, looking at the right material. So let's say we're cutting this on mild steel and we're cutting fine cut, so we're doing something thin. So what you need to do is get used to doing this where you're going to get a caliper and zero it out, measure the thickness, and we're at 27 thou, 26 thou. Now we're going to go convert that to gauge. And so I just looked that up. I had a printout of one here once and it disappeared. So yeah, we should put it right up there.
Right here, where we can put all that stuff up there.
And I, like I said, I had it.
Cut a hole to the other side.
I had it. So
We're learning the
sheet metal gauge to decimal chart.
Have our first poster that we need to order.
So gauge, so we know that it was 27 thousandths, right? So that would be 23 gauge. There is no 23 gauge, there's 22 and 24. So we can just see, were we closer to one or the other? Yeah, if anything, we might have been like 24 gauge. So, and there's not much difference when you start looking across. So it wants this at 30 amps, and it wants a few other things in here. So the cut height, and what we're looking for here is kerf. Okay, so kerf width is the same thing here as tool size. So the kerf is the width of the cut that you make, whether it's on a saw or on a plasma. So if we are a kerf of 039, we would go into this tool size, and it's weird, when you click on it, it comes over here as 0, and you just put in 0.039. That's our kerf width. And what that's important for is this offset check mark. So right here is an offset. And by telling it that the tool is 39 thousandths in diameter, that's the width, and it even shows a little dimension there. It's saying we're going to cut 39 thousandths wide, meaning it's going to move 20 thousandths over offset so that your part ends up true size. And I did a little experiment on here once where I really was trying to dial it in, and I made a bunch of circles that were 1 inch diameter.
Right.
And I kept changing the kerf until the circles ended up exactly 1 inch, because it was important to me that I was making something of a certain size. So I was dialing in the kerf for a given head, material, gauge, like all that. It was really important to me. On a letter, I don't care, right? I don't care if it gets that width right. So whatever. But I was making a part that mattered. So you look up that goes into kerf. Now that's the last we can set up here. We send it back over. Now the rest of the settings come into play. I usually just work my way down the chart so I don't miss anything. So cutting speed 1 and 2. Cutting speed 1 is when it's on a straight trajectory. It's that speed. When it gets into something really fine or detailed and it's doing some lettering or something like that, is going to be where it drops down to cutting speed slow. So we're going to look across. We're on fine cut low speed. So 24 gauge. So our cutting speed is 150. Okay. And so what we would do is put in 150 here. And apparently the rule of thumb for the slow is half.
Okay.
And so you can tune that. Again, it's so much about settings, and you dial them in and then you make a million signs the same way. And we just don't do that. And the bummer is we never get a chance to dial in a setting. We do it once and then you're like, it was good enough or it wasn't good enough. So if there's a question and you're doing something, say, that's really highly detailed, you might want to cut one object and see how it comes out, and then change your cutting speed until it looks right. Okay, so that's cutting speed. Next one, cutting height. That's this 140 cut height. So we're going to change that one, 0.14. This is a weird one. This has cutting height, THC, with a V for voltage. What that really means is voltage.
Okay.
And so 24 gauge reading across is 97 volts. And that is one of the most confusing ones because it says cutting height, but the hint is that it's V. So that's 97. Tab. Piercing height is pierce height 140. So 0.14. Piercing time, they recommended you just always leave it 500 milliseconds, half second. So even though here it says pierce delay would be 100 milliseconds, they've just said, just leave it at half a second. So all right, so it just stays at 500. Floating height just also stays at ½ inch. That's how far the head moves off of the workpiece to traverse. Now maybe if you're cutting something that has lots of little pieces that can get jacked up in there, you want to increase that. When I was cutting these were all of the lighting tracks for the sign.
Yeah.
Every one of these, as soon as it got done cutting, would tip like this and end up in the machine like that high up in the air. So what I had to do is, after every single cut, sitting here, you have to hit stop here. So it'll cut something, and you can't look at the machine because it'll burn your eyes out, right? So I'm looking at the wall, and you're hearing it, and you're seeing it's all bright on the wall, you're hearing it, and then as soon as that stops, and you see it traversing, you sit stop. Then you look over there, and you'll see a piece sticking out of the bed. You walk over there, pull the piece out, come back over here, and hit play.
Okay, so
And it
I
does
have
the
a
next
quick
piece.
question. Can you put the welder's helmet on?
You can. You won't be able to see anything else.
Right, but
You couldn't see the
while
screen.
it's cutting, you could have the helmet on.
You can.
And keep watching it, and
You
then
can watch it through this screen. That's a welding helmet screen. That entire screen is a welding helmet.
so you could be on the other side of it
Yep.
and look. But then you don't have the computer right there, so you would have
I've
to
done
have
it
the.
where I bring this around here,
Right.
and I have it right up to here, and I go behind it for the cut.
look, yeah.
And I go in front of it to
Okay.
see, did it fall?
Right.
I also, when I'm here by myself, I actually go like this, and I block just the plasma. And then I go like this when it's done, and then I see it didn't fall, and I block it, and I have to close one eye, right?
That scares
So
me a
I got
lot.
one eye, and I'm blocking the plasma, and then I go like this, and I'm like, it's fine, it's fine. Oh, pause.
I don't like that.
And I run over
Okay,
there. So
that makes me nervous.
yeah,
Greg.
I wouldn't recommend that for a student.
No,
Because,
I
you
wouldn't
know,
recommend that for anybody. I'd rather wear the helmet and go like this.
Oh yeah, but it's too fast. Yeah, so this enables me, I have one finger here,
Now,
I'm going like
now the
this.
speed on that though is you set the speed, right?
It's 150 inches per minute. I mean, it's going
So
going
fast.
and then it jumps. Bless you. It jumps to the next article, right? And it's moving. Now, when you're doing a part like this, you don't have to worry about it. It's just cutting.
Yeah.
Nothing is dropping through. It's only when it did the final perimeter, and it's smart enough to know to do the perimeter last. It does all this other little stuff first. And then when it's all done. Now, I will warn you, there's a weird thing here. Look at these two charts. So, if you look at, like over here, so this is stainless, mild steel, fine cut, low speed, right? Everything's the same except for the stainless. You have 24 gauge, 150, 150. The arc voltage is a little different, right? This is 73, this is 97. Kerf width 39, 33, so they're only faintly different. Look at pierce height is 140, yeah. Cutting height 140, yeah.
Cutting height is
20
tiny.
thousandths. It's saying,
tiny, tiny, tiny.
It's saying it wants the head that far off the material. There's burrs that are taller than that. I think it's a typo.
Why don't we just put an X on that and put a 0.5 on?
Well, then it's too high. So what I've done is I looked at the other stainless. See, also O2. I've looked online to verify this. I can't find anything where people have talked about it. So I generally set it to the 0.14 on both.
Should we just write that in there?
We probably should just
Yeah.
remind ourselves. I mean,
Yeah,
I
let's
know
get a
it now
pen.
because look how
I'm gonna
absurd
forget
that
that.
is.
Yeah, I'm gonna forget that. Hold on.
1.2 is crazy.
Yeah, let's do that. Because that's the kind of thing that.
Yeah, I don't. And, you know, we should test it and like see if there's, you know, if one comes out. But just to put it in perspective, that burr is taller than 20 thousandths.
For sure.
So there's no way that number's right. So,
Right.
you know, whatever. Okay, so when you want to get this thing started is the toughest part about running this whole machine is this corner is as if you're standing at the other end of the plasma machine.
Right. So on that corner,
Yeah, it would be this corner.
this corner over here, that's the 0, 0.
Yeah.
Yeah. So that's 0, 0. That's positive X, and this is positive Y.
Exactly. Yeah, we
Okay.
have 8 feet of
So
Y.
0, 0 there. Okay.
And what we're gonna do?
We can put. You know what? We can put a label over there. 0, 0. We can probably make a little label that says 0.
I made an angle thing that puts it in at 0, 0. But then I'm actually not sure if it's right. So this would be 0, 0. So go ahead.
You don't have 0, set though. You set it manually, correct?
Correct. Go ahead and say there's something there that says is not 0 but calibrate XY.
Is that on the left side?
Yeah. Do you see there's a little boxes that say X?
Reference Z, X,
Re-
Y.
Yep. Just do reference XY
Okay.
and watch what it's going to do. It's going to come over and it's going to use this proximity sensor, and the light's going to turn red right here when this metal reaches this, and that's going to reference X. And the light's going to be right on the back of this. You'll see it from his side, and it's going to be referenced there.
There's
Oh,
Y.
yep.
So that's X. Now it's going to come over, and there's the sensor right there. And it's going to sense when this thing gets close. And so now you can see that this becomes 0, 0. Now, you don't have to start your job there, but sometimes when this thing says machined not referenced,
Yeah.
this is what it wants to see. And you just say reference XY.
It's
and
like the shop bot. You just need to find 0, 0.
you
to
need to
set.
find 0, 0. Exactly. And then if we had a piece of material, so now with the right mouse button,
Yep.
the right arrow button, just go to the right a little bit.
Wait, so is it my right?
Yes, it's your right on the,
Yeah.
and it's from where I'm standing.
Yes,
Is-
okay.
Your right is my right. Yep, there we go. And now that's good. And then go Y up. Yep. And then that's good. So let's just say that's where we wanted to have our XY. Then, and this is the part where I have screwed up the most.
Put the ground table.
If you forget the ground cable, it will run.
Yeah.
It does a horrible job cutting. It messes up all your work. Your job looks horrible. It messes up your workpiece. Nothing works, but it doesn't tell you. And it's a matter of that it needs that. Somewhere, anywhere on your part. But it's clamped here, so it gets a really bad grounding path through the metal, through the tank, up onto these rusty pieces, contact with. So it barely works, but it ruins your part.
And it will run.
And it will run.
Can you use it as a clamp to clamp it onto these things?
Except that this is flat going this way, and these fins are going this way, and so
That's how we took the
yeah, it doesn't work well.
I just was trying to see if we can kill two birds with one stone.
Yeah, gravity and friction are the things that keep it in location. So the next thing we're going to do is back on the machine,
Yep.
and it's to tell it where things are and what it is. And that piece of metal obviously is like the wrong one, but we would say we want this corner to be where the plasma currently is. And so what you do is you just say, see right there, this little green arrow?
Yeah.
We're just saying, right now you are here. And the part will be made there and there.
Okay.
So from that, it's that direction.
Got it.
And sometimes when it still says up here, it'll say in red, not referenced. Well, we just did X and Y, so what it's looking for is to reference Z. And you can do it separately. And it's going to go
Maybe the hold down.
Did it do it? Oh, it was already up, so maybe it's already referenced. So now it has that. Now what you're going to do is you go page down, not down arrow, and you're going to watch. And watch very carefully. You're going to look for the ripple in the water. I think we touched.
Yep. There's the
Right? So I'm going to go up a little bit, down a tiny bit. There.
Yeah.
We touched, and we're going to tell it Z equals 0 right here. That's different than referencing Z. Now we're telling it Z equals 0. And now I'm going to page up to get it started. Right? And now it's going to start if I say go to the next stage of the program. The first thing it's going to do is cut that line, and I did that by saying go to the beginning of the program
preview that way.
and go to the next one. Now I can look down here and see my power supply is off. So that thing that said that we wanted to be at 30 amps is on the back side of this machine. You have to turn it on, you have to dial the dial until it says 30 amps. With that off, there's a cool function. I'm gonna hit run. And it's gonna go run thinking it's doing the job. Now, oh, it's not even hitting metal, so it's not even gonna do it. But the cool thing is you can run
simulate
through
it, yeah.
your entire program. The other thing you can do is, let's say we're trying to fit this into a piece of material. You can go, where is, like let's say, where's this hole? I can move this
To get to the hole. And then look and
and I
see
can
where
look
the head
over there and
is.
say, oh, it's in the right place. I can also move this to where the edge of my metal is, and I can look at my part and see, oh, did I have enough metal? So you do all that stuff ahead of time to make sure your part will fit on your part and all that jazz. And then you can also run it with no juice and see how it's all going to come out. And then when it's all good that you want it to happen, you turn that on, change it to 30 amps, and then you hit run, but you have to make sure you go all the way back to the beginning of the program. And now when you hit run, it's going to start from scratch and go. So that's the basics.
Boom.
Cool. Thank you.